Welcome to MLOps Live, a podcast by Neptune.ai. Today we have a special episode with our CEO, Piotr Niedźwiedź. Every couple of months, Piotr dives into a one-on-one discussion with an expert practitioner doing machine learning in production. Tune in for a no-fluff, in-depth MLOps conversation.
So today we have an outlier, definitely. LinkedIn outlier, MLOps engineer outlier. Why I said outlier? Aurimas, like 7 months ago, it would be hard to find you on LinkedIn. Today, if I am following you, and if somebody following you, most of the days you will find colorful diagrams explaining different components and setups around MLOps. And they are not only like they're written they are displayed in a nice way. At the same time, I would say they're pretty deep technically and correct technically. It is what I like. Can you tell us, to those who are not following you yet, what's your background and how you became one of the, if not the most active and followed MLOps person on LinkedIn?
Okay, let me give it a try. So first of all, thank you for having me here, and definitely thank you for your kind words. It definitely means a lot to me. So yeah, as you mentioned, 7 months ago, I definitely was not known on LinkedIn. And I think that even 3 months ago, probably not that much, but it changed a little bit and very quickly. But maybe let's get back to that a little bit later, and I'll just give a short intro to who I am and what my background is. So yep, I have tried a lot of hats in my career. Most of my hats were data related. So I have been a data analyst, I have been a data scientist, I have been data engineer, machine learning engineer, cloud engineer. I was leading teams of cloud engineers, machine learning engineers, and data engineers. And now in my final role, I am actually an MLOps engineer. So probably different people would think about different things about what an MLOps engineer is, but maybe we'll touch something about that later on today. Yeah, and then actually only 7 months ago, as you mentioned, I also started creating content. I haven't written anything on LinkedIn before that, apart from some regular posts about, for example, an IPO of one company that I was working for. And yeah, I started off as, I didn't really have a concrete plan of what I want to write about. I knew that it was most likely to be about MLOps because I was doing it back then, and I really love the concept and all of the, not only technical stuff, but also leadership stuff. So team management and how teams should look like in an organization for it to function efficiently. So actually I started writing about that and not the technical stuff. So I started writing about what is an MLOps team, what is an MLOps platform team, why do we even need one of those, and what does it mean in a broader context of a company. It was pretty successful, I would say. I was also drawing some diagrams about that. So if you would scroll the history of my posts to 6 months ago, you would see some very amateur drawings of circles with team names around them connecting. But yeah, then eventually I grew my following a little bit. Then I started writing a little bit more technical things. And then one day, some of the posts just started hitting lots of likes.
Do you remember what was the post? The breakthrough post.
It wasn't one single post, probably 2 or 3 almost in the row. Yeah, actually, it was a little bit weird because the first one, if I believe so, no, I would be lying if I would say that the first ones that would start hitting more likes were diagrams around the full life cycle of data, up until from data generation till the deployment to production.
Deployment of production of data or model?
No, the model. So it would start at the raw data ingestion. It would end up at deployment of a model and then monitoring systems connected to it as well. You wouldn't see those now in my feed.
Yeah, there are more zoom in, right?
Yes, exactly. Yeah. But I had this one template on which I would recycle, and then I would dig deeper into each of the components of it. So these ones were the ones that would hit a little bit, like 100 likes or whatever, which is already quite a lot. But then at one point in time, I just decided to put part of my what I post on LinkedIn into a newsletter. And I had to come up with a template of my post picture. So I would basically put everything that I talk about into the same template, very similar template, explaining different things. And those first two posts actually, I wouldn't say exploded, but they definitely were better than previous ones. So up until 500 likes or even 700. Then I did that for a few weeks until some of them started hitting 1,500. Eventually, a few of them did hit 2.5 thousand. And I was very lucky because I never went viral. So 2.5 thousand to me is not yet viral, right? It's still the amount of
organically growing, right?
Yes, still the amount
I think
of
it is healthy thing. It is something that's it's an indicator that you are doing something right, not just one lucky event, I would say.
Maybe I can't say for sure, but hopefully so. Yeah, and then the following continued to grow, and now I am where I am. I'm really happy about that, and I really love what I do. So,
and Aurimas, getting back to your background.
Yes,
you've been leading different types of teams, and in particular, you've been leading data platform team.
Yes.
How would you make a border between data platform team and MLOps? Let's call it MLOps platform team. Firstly, how are they different, and why do we even need MLOps platform team if we had data platform team?
I wouldn't necessarily draw a distinct line between these two. There are two separate things. One of them is ML platform. Another one is data platform. Data platform is usually targeted mostly towards data engineers and analytical engineers and analysts. So it would include everything starting from orchestration for data engineering ETL flows till actually database management, so data warehouse management, till the BI tooling, which then are mounted on top of data warehouses so that you can display your data in nice graphs to business people. So that's a data platform. When it comes to ML platform, it is more targeted towards frameworks and tooling that machine learning engineers use day-to-day, or data scientists use day-to-day to implement the MLOps workflow end-to-end. It usually does not involve anything which would allow the practitioner to display his results. You would use probably BI tooling for that. But then again, when it comes to team structure, I wouldn't say that it necessarily has to be a different team, a separate team, but the platforms that the team manages are different. Naturally, once another team, but the company grows, it is natural to split these because the needs outgrow the size of a single team that could deliver, a single team could deliver. And eventually also a skill set is a little bit different, right? So usually data platform engineers will be either data engineers who went and became cloud engineers, or cloud engineers who want to meddle with data a little bit more. When it comes to machine learning engineers, then definitely those people need to know at least a little bit about machine learning to do what we do, but not always be super experts in it. And so maybe it's just one more thought. So usually how startups grow or new companies grow is that they do not start with machine learning. So we start with analytics because this is what management needs to understand its business and maybe do some decisions on the data that we saw historically without necessarily doing any.
I wouldn't fully agree that it happens in early startups. But yeah, it depends, of course. But in tech startups, I'm biased, right? I've been always around tech startups, and management was technical, and especially maybe it's going to change, but especially in the last years, some of the startups. Sometimes we were meeting such startups among our users or customers. They call themselves AI first startups, right? So they are starting having like particular models in mind as a core of their product. But of course, I would definitely agree in that when it comes to more product companies, not so focused on AI, then very often you're right.
There are different types of companies. Yes, for sure. Mostly talking about maybe e-commerce who is just starting out. So you build out the software which hosts your website, and then you sometimes even would treat an analyst as an afterthought, which is not good. But the machine learning engineers come even after that, right? So you would design your system for analytics purposes, and at least that's what I've seen in my career. And then naturally, data platform team would be the first one to form. And even though like ideas around machine learning are starting in the company, what kind of data products you could deploy to production to improve your revenue streams, but then it also makes sense for a data platform team to also take in that load as well initially until it grows to the size where you need to split. That's what I would think.
And Aurimas, when do you think, like from your experience and what you've seen, when it makes sense to start thinking about data platform team or ML platform team? It sounds like platform, sounds like something that should serve many people,
yes.
Right? What is the right time to consider it?
Yeah, so I'm actually a fan of team topologies. Probably lots of listeners might know this. So it's a kind of popular book, and it creates a theory around how a company team structure should be implemented for a fastest possible flow. And it says that there should be 4 types of teams: a platform team, a stream-aligned team, an enablement team, and a complicated subsystem team. But in there, they also explain why you need a platform team. And the main purpose of it is reduction of cognitive load on stream-aligned teams. And stream-aligned teams are what people would usually call a functional team, meaning that it has all of the people that they need to actually roll out the entirety of their product or part of the product that they are responsible for without additional interactions with our team. And naturally, once again, as a new company, you would start as a single team. Probably you would have a few backend engineers, you would have a designer, a front-end engineer, maybe not already, but probably an ops person, and hopefully a data person from the very beginning, but usually that, okay, not from the very beginning, but as soon as you start generating data assets for analytics, I would say hire a data person. It does not need
we have such a team, there are 20 people. How big we need to get? Start thinking about data platform team or ML platform team.
So for data platform team, I would say that you still need to at least have that first initial team split into, it will eventually split into 2 teams responsible for different parts of the product and eventually into 3 teams. So I would say once you have 3 teams, start considering it. So start pulling all of the ideas, all of the common things that those 3 teams are using and having, and put them into the platform team. The best way probably to do that would also be to take a person or 2 from those already existing teams and make them the core of data platform team and not hire someone from outside. Maybe 1 person from outside plus 2 that are already in the stream-aligned teams.
And when it comes to ML platform teams, the same rules applies or?
Yes, but naturally, this would not be so soon in the life cycle of the company, but stream-aligned teams should eventually also have a machine learning engineer or a data scientist in those teams. So eventually they will build their own mini platforms inside of teams. That's unavoidable. And that's also
we see it very often.
That's also one of the biggest problems that MLOps platforms try to solve. They want to normalize everything and don't allow teams to diverge too much. Of course, there will be divergence because there will be specific needs per team, but hopefully only very little.
So looking from, assuming there is the needs, following those rules for data platform team and MLOps or ML platform team, what other teams like stream-aligned teams should expect to get from data platform team and from ML platform team?
So data platform and ML platform teams both provide the same thing, but to different stakeholders. And that thing is a framework and a platform to work against so that they can implement their day-to-day end-to-end life cycles more easily. What that thing that they get is definitely different between the companies, but let's say given a machine learning platform team, that could be a framework in a form of, let's say, template repositories. This is a very popular way of implementing MLOps frameworks. So you prepare a repository template that a team can then pull and work in it, and it would have very specifically defined where certain elements of your code should go into and how Git interactions work and how those Git interactions, what do they create in a CI/CD lifecycle and what are your expected outputs.
And Aurimas, when you said a template here, in this context, what the template is. Is it a document in Notion?
So it's actually usually it would be exactly a Git repository, and not a single one. Usually it will be a repository per specific model deployment type even. So if you would have, let's say, deployment as a REST API, would have deployment as a stream application or a batch application, that would be most likely 3 separate repositories, GitHub repositories, which do not have anything functional, like business specific. It only has boilerplate code, which is a framework, which you, when implement, you can expect certain specific actions happen. And once you trigger those actions, then also MLOps platform team create all of the workflows that should happen for this model to actually end up in production without any additional interaction from a product team, which is not ML team, but streamline team who has either ML engineers or data scientists in them who use that template. This is just an example. There are more ways to implement it, but this is one of the most popular ones. Even AWS itself has a very nice blog post around it. Not a blog post around it, but I don't remember which company implemented it, but it defined in detail that we had a lot of templates. And basically a job of MLOps engineer would be just to increase the scope of those templates, create more templates, because we had so many use cases, different use cases in the company.
Okay, and those templates to work, I guess they need other tools, services to be around, right?
Yes.
And I remember we had the discussion before this recording, and I mentioned, I wrote an article about where I said that we should think about MLOps as an extension to DevOps, is what I wrote. Some people like it, some people really didn't like it. I think it's usually good when there is some level of debate. Anyway, I ask you what you think about, where do you think DevOps stack, DevOps engineers, where are they in this picture? We talk about data platform team and data platform stack templates, MLOps team stack, like those models eventually, if we are talking about models that are on production, they are around products, usually software products. Software products, most of the time, are managed by DevOps, by ops teams. How do you see those teams collaborate? Yeah, and when it comes to tech stack, where do you see what we are missing if we look at the typical DevOps stack? DevOps stacks are pretty much standardized. Of course, different vendors, but I would say it's way more mature market than MLOps.
Sure. So first of all, I love your definition of it. Like definitely MLOps is an extension of DevOps. And if you would also scroll in my posts to 7 months ago, the post which went out the very first week I started posting, and it had this diagram where I just placed DevOps and then extended it a little bit and then called it MLOps. And it was one of my first semi-viral posts because I had then just 1,200 followers and it reached 220 likes, I think. So it was huge at that point. And yeah,
I didn't see it.
It's 7 months ago.
Yeah, but I was drawing similar, like based on your description, similar diagram during one of the BOD, Board of Director meetings of Neptune, where I was asked, okay, like, Piotr, what do you mean by extension of DevOps? But maybe you were first with this idea then.
I don't know. No, definitely maybe not. Probably you were brewing it in your head for the last, 5 years, because that's how long Neptune, I think, exists, right? Around 5 years.
Like 4, something like that.
Yeah. Essentially, yes. So everything that comes to development side, the development deployment side, to me, it's just pure, I wouldn't call it even DevOps, it's just the software engineer. Yeah, it's DevOps, but not necessarily including DevOps engineers, because that is also a biggest term. Every DevOps practice can be applied to MLOps when it comes to deployment. Machine learning applications, however, are a little bit harder to monitor in production, because while you also need to monitor everything that you would need for a standard software application, you need to monitor additional things which are not deterministic, which basically is the usually distribution changes of the data that are coming into the models that you haven't seen before, right? So this is called feature drift. It could also be eventually a concept drift, but it's probably not for this meeting to discuss. So this part is clear. Then you need to attach additional things like training pipelines, which, well, naturally, they are not part of DevOps because software engineers don't do that, right?
But yes, like, I would say, yeah, like we software engineers don't train software, right? But they build software and they test software. They're doing unit tests, they're doing end-to-end tests. So it should be deterministic. It's not all it is, but yeah, I see some level of analogy, but in details they are different.
But still, most of the, not the most, but machine learning pipeline concepts could be directly translated into how DevOps works, standard practices work, right? For example, a machine learning pipeline is just an artifact. The pipeline itself is deterministic. Only the data that is coming into the model is not. So you can
if we set seats fixed for random generators.
So
right?
For training, yes. For deployment, not anymore, because random data is coming in. So no seed will help you there.
Yeah.
But the pipeline itself, it's just pure code, usually, most of the frameworks. And you can unit test it, you can integration test it. So you can make sure that it works. It's a little bit more complicated when it comes to like benchmarking different models against each other, right?
So looking from the tech stack and comparing MLOps to DevOps, what we are really missing? You mentioned models on production are harder to monitor than software running on production because there is a superset of things you need to monitor, right? You need to monitor what you monitor for software plus data-related, drift-related concepts.
Yes.
What else is missing?
There's a lot of data quality checks happening before the model is trained as well, not only after the predictions are being made. Definitely a term called data profiling is probably not what you would find in the general software engineering, which is probably one thing. Another thing that these pipelines that are machine learning pipelines, we are more related, I would say, to data engineering rather than software engineering, because that's also what software engineers usually don't do. Of course, there is, I would say that, yeah, experiment tracking is yet another thing, right? Because I never seen a software engineer even talk about these concepts. I would like to say that feature stores are something that is specific to machine learning, but I wouldn't probably, because to me, it's also a little bit, to me, it's data engineering, right? Because we have been doing feature stores before MLOps movement, right? It's just a key value store with a specific API faced before it, right? So
what is so different? Why we cannot have, let's use MongoDB as feature store or...
But we are using it underneath. Like I didn't see anyone use Mongo yet. Could definitely be implementation detail. People are using DynamoDB, Redis for that, right? So how feature store systems themselves improve the experience of a user is, first of all, they make features shareable and discoverable. Second, they ensure that you only do feature engineering once. So you don't need to do it again once you fetch data from, for example, online feature store, which is very important as the data comes in either in stream form or batch form. You apply the feature engineering once, and then you expose that data to all of the users. It can't happen anywhere else, because if it does, you can't avoid training serving skew. It's impossible. Then, yeah, and to be honest, probably that's mostly it. And it doesn't solve many more problems, but these problems are so critical and so important to business that it's worth investing in this system, and it has to be stable because, and when I say stable, it can't have downtimes, for example. So managing something yourself would be very problematic, and that's it. So it's estimated that for you to create, not necessarily estimated, but we had some estimations in my previous companies that we also were thinking, should we build our own or should we buy something? Yeah. So building your own would take, I don't know, a year plus probably for 2 very senior engineers. And it would just cover probably basic needs of yours. If you want to enable cataloging of features, discoverability, that's yet another metadata layer, which wouldn't probably be even in the plans for that in-house built feature store.
So talking about feature stores and the relation to dataset management, when I am talking with our users, customers, we from time to, I would say even often, okay, what would be my recommendation when it comes to data versioning? And it's something that I ask you about, how data versioning, how is it related with feature stores? Like if we compare, for instance, I think that's when you say data versioning in MLOps space, people would say DVC as a, like, it is the first thing that comes to mind. How do you compare those two?
Well, data versioning is actually neither data science nor machine learning term, right? Data versioning was done for countless of years in data engineering world. So there are also different tools that could be used without feature stores and DVC to version data. A very good example would be just using Delta Lake, right? Because it's just a metadata layer on top of your data in some object storage, which allows you to time travel, for example, to a specific snapshot of the data. Then comparing feature stores to DVC, these are completely different concepts that also don't necessarily integrate with each other. So DVC was created for data scientists so that we wouldn't need to implement something that it does themselves, which is basically pointing to a specific data set in a specific storage in a specific branch on Git, right? So we chose Git for this implementation.
And to some extent also being able to replicate or understand how it was created, right? Because
But you could do it, not necessarily the creation part yourself, but let's say the versioning, you could do it very easily, right? You would have a YAML file in your Git, which would point to a specific S3 location. And in a specific branch, you would have different configuration files. So that's already kind of data versioning for you, right? So, but what DVC wants to do is to normalize how it's done, right? Because lots of people are doing it in different ways. When it comes to features,
when you compare it to feature store, if I had feature store, how it will work now?
So feature store, it doesn't provide this DVC functionality out of the box, but it provides feature versioning in data engineering way, I would say. So usually what you would do with a feature store, you would query batch data set for training, right? And you want to version that. That's just what you want to do with data version. And feature stores usually provide an API, not an API, but so-called feature views, called differently in different feature store by different feature store providers. And these, I would say, almost must have at least 2 timestamps in them. One of them is when the feature was created, because it could have been created somewhere at some specific point in time. And when was this feature actually inputted into the feature stores? When did it appear in feature store? And feature store APIs also provide this thing called point-in-time joins or point-in-time feature retrievals. So you would usually, how you would do that, you would have a data set which indicates entity IDs. So entity could be a user, for example. And then for each of these entity IDs, you would also provide a timestamp. And that timestamp means return me a feature view of this entity, how it looked at this specific timestamp at this specific point in time in the feature store. And these features could be updated. And with each update, there would be a new feature ingestion. I don't know how that should be called, but maybe let's call it feature ingestion timestamp. And at any point in time, you can retrieve your features, how they looked at that point in time, even with different timestamps for each specific entity.
So Aurimas has a question then. So where the actual data, where do you store it? Like, do you think as a feature store as also storage, or it is abstraction on top of the storage?
Yes. So it is abstraction on top of the storage. And however the underlying infrastructure and databases look like, it's up to the provider to say. It could be open source provider, it could be not open source, right? But however, that library, or it's probably a library usually implemented, that it defines what kind of backend storages you can use. Of course, naturally, most of the times you will see S3 or Google Cloud Storage for batch, and you would see either the DynamoDB or Cassandra or Redis for online.
Okay, and I want to ask you about an example, okay, to better understand this setup. Assuming that somebody would like to set up feature store.
You mean in-house built feature store, right?
No. I'm not recommending building feature stores neither, right?
Yeah.
There are a few on the market and I heard they are pretty good. But I'm talking about setting things up because as you said, like feature store itself, like it is an abstraction on top of the storage. So let's say that we have a SaaS business with and we have, of course, our internal database. Let's call it MySQL. We are using Heap for product analytics. So in Heap, we are having events. People are creating accounts, doing some actions, etc. And we use something because we will be building lead scoring system. Okay. So we have, again, MySQL of our SaaS. We have Heap where we have events of actions of users. And we have some demographic data about companies who are registering to our SaaS. coming from Clearbit through API. How I would, and now I want to install some feature store, how it would work.
So first of all, it's very important to distinguish between feature store ingestion and feature store serving parts, right? So feature store is a library or a framework on top of storage, but it has to have two sides, ingestion and serving. So however, the feature store itself stores the features that it has already ingested. It's up to the feature store provider. Let's say we don't really care about that because it's abstracted for us. It will just work, right? So when it comes to ingesting from outside sources, as you mentioned, like databases or third-party APIs, this requires a data engineering flow. So it's less machine learning problem, more a data engineering problem. And it requires to ETL all of that data up until the feature store. So how it could look like if you want to do it in batch, like not real time. Of course, you could do real time here as well. So batch would look most probably, you would do a database dump and you would naturally check the data's quality. You would do some ETL transformations. You would construct your entities in the pipeline. You would create most likely a data mart in your data warehouse. And data mart is already curated data prepared for consumption. It could be used by a BI tool to plot it, or you could mount a feature store on top of it, and feature store would have a batch ingest API, which would optionally on a given time period would extract the data from your mart, would put it inside of its internal storage system and make it available via the serving APIs. When it comes to your APIs, third-party APIs, you would also probably have a data engineering flow, which would continuously extract the data from the APIs. Probably, since it's an API, it could be either real-time extraction or just batch REST API gets. You would place that data most likely into Kafka, then push it downstream into the similar system like you did with your internal database, and then perform the same actions, prepare a data mart, mount feature store on top of it, and ingest the data. You could do all of it in real time. So you could connect a CDC stream to your internal database and push every transaction in your database into Kafka and do the data modeling in real time and ingest this data through Kafka into the feature store in real time. And you would even be able then to query the data from feature store, serving APIs in real time. You could do the same probably with your third-party APIs, because usually third-party APIs as well, they usually have a push API next to the REST API. So you would then use push API, which would push your data into your Kafka topics, same as the CDC stream from database, and you can serve the features in real time.
And now I want to connect it with versioning. So I understand, like with Kafka setup, I can get those features from feature store in kind of real time, but when I would like to do then, let's say, point-in-time query, I would like to get data that I used week ago to train the model.
Yes. So
how it would work?
So the feature stores, usually a good feature store has 4 APIs: batch ingest, real-time ingest for data marts or streams, log streams, and they also have 2 types of serving APIs: batch and real-time. Data that comes into feature store is always replicated into both batch and real-time. Real-time only has the latest data, so the current state of your feature vectors. Batch API, not API, but also storage underneath, has all of the historical data. So regardless if you ingest it in real-time or batch, you will also always have it in batch to query. And it's also usually done through CDC. So imagine you ingest your data through a real-time ingestion API, probably somewhere inside of a feature store system, a Flink job or a Spark job runs on top of that data, transforms it into features, and writes it into real-time storage, which could be Redis or DynamoDB. Then you can always mount a CDC connection from Dynamo or Redis into S3, and you will always have historical data. So it's nothing different if you ingest it in real time or batch. Eventually, it will be in both.
So then to version dataset, I just need to know kind of a query to feature store and date.
Yes, but additional problem here is that usually you need to provide a entity ID vector. So which entities do you want to query? Because feature stores don't work like databases. You can't run a complex query on top of your feature view to only get a subset of entities. You will need to provide feature store with entity list of entities that you want to retrieve. So then these entity lists have to be constructed outside of feature store system. So I would say that these might need versioning.
Okay. Where would you store those?
There are multiple ways as well. DVC could be used for this, but just storing them in S3 and pointing in your experiment tracker to this location, I would say is good enough.
So from experiment, okay, yeah, I am running product of function of experiment tracker. So I would need to version data sets with feature store. I would need to version on one hand entities that can be on S3, so pointer to S3.
Unless we don't change.
Query and time. Oh yeah, of course.
Because you need to get those entities from somewhere. So there are ways, for example, you could get those same entities from those data marts that are used to ingest into feature store as an example.
Okay, so when it comes to, coming back to MLOps stack and what we really need to add or what is this extension, right? Like, okay, what is missing? So we have a feature store, it solves a lot of problems. We have experiment tracker. What about pipelining frameworks? How does it work? Like, let's say Airflow and feature store. Like how this should be integrated? Or we don't need Airflow if we have feature store?
We do. So these are two completely different worlds. The pipelining systems, I wouldn't call Airflow a pipelining system. I will call Airflow a orchestrator. Pipelining systems would be probably something like ZenML or SageMaker pipelines, because I don't think that they actually even contain cron invocation by themselves. I think they have to be invoked from somewhere else. Maybe ZenML is different, but eventually these systems can run anything, at least the Airflow. It can run anything, can run Java, it can run PHP, it can run Bash, it can run Python, right? So some of them, I would guess, integrates with certain experiment tracking systems. You mentioned feature stores as well, right? So feature store is completely separate. They have their own separate APIs. If you schedule a job, a machine learning job or training, for example, you will have a step which will query the API.
One of the steps would be get from let's say that we want to train a model or retrain a model from kind of scratch, right? We need to get the particular snapshot of data. So it is one of the steps of, let's say, Airflow pipeline. This step would ask feature store for particular snapshot of data.
Yeah.
And this batch API?
Batch get API, yes.
Okay.
Historical. Batch get historical API, because there's also two types of APIs for real time. You want to have both a single vector and a batch get. So let's say 5 vectors in the very low latency, right? So sometimes people get confused when you say you use batch get in two separate. This would be batch get historical data.
Okay. What can be the next step then? So we have data somewhere.
First of all, we need to get a entity ID vector. You get it probably from your data mart or raw data somewhere. You ask your feature store for a list of specific features for this entity list. You retrieve that. Then you naturally already save some metadata to the experiment tracker in the same step. Then what I would do, not necessarily needed for every machine learning pipeline, I would do data profiling. So you got your data set, retrieve your data set. You want to save profile of it somewhere. Could be also experiment tracker or metadata storage as Neptune. You need that because let's say you run the same pipeline again, but on a different feature set. You want to be able to compare these two together against each other.
Distribution of features in the datasets, right?
Yeah, could be a different thing, but mostly you could call it a distribution of each feature in different datasets. Then if everything is fine, so if the quality is good, then you continue. If not, you can already short circuit here. This is a error, you could say. Not error, but alarm. The next step naturally would be to take this data and train a model on it. You train a model on it, maybe do some hyperparameter optimization already here. You can branch out your task a little bit, save all of the experiment metadata. So when I say experiment metadata is mostly where the experiment metrics, the term, not operational, but
are we talking about things like accuracy?
But what's the term, right?
Training metrics, I would call it.
Let's call them training metrics. So you save all of these training metrics for different runs so that you know which one is better. So you could naturally already not necessarily stop here, but you need to output the model which was trained. But if you do hyperparameter optimization, there will be different models for each of the sets. So you need to compare them somehow. So I would say that if you are doing hyperparameter optimization, you could either choose automatically which one you want to save, or if you want to do some manual intersection, probably you would have sub rules. So you would save, let's say, 5 best of 1000 which you trained, and once you save 5 best ones, the metadata for them is saved into Neptune, for example. Then you go into the UI, you compare them against each other, choose the best ones, the best one, and then naturally there is another step. Since the model is already saved, it should already also be saved into a model registry, right? So it could be standalone model registry, it could be integrated, but it needs to have one-to-one mapping to each experiment that is saved in the experiment tracker. You choose the best one, you change, not necessarily change, but tag the best model, which corresponds to that experiment, and you release it to production. What happens later is also up to you, but usually you would hook that system to a deployment pipeline. So once you change the state to production, deployment pipeline kicks off and deploys the model to whatever type of model deployment you need, right?
And talking about model deployment,
maybe I missed something. Yeah, go on.
We can make it always more complex. Anyway, thanks for going step by step and walking us through it. When it comes to model deployment, I was thinking that from more abstract perspective, we can think when we have a trained model and we want to evaluate a model on example or set of examples, we can think about it as a feature, like execution of calculating features, more complex features in more sophisticated way, of course, depending on the model, but it is, for me, conceptually, to some extent, similar. So if it is similar, do we need model serving components? Can we serve models through feature store, or?
Yeah, so this concept is still a little bit hard on my head, but let's try and dig a little bit deeper. So you're saying basically that a model which you trained, you would like to apply a certain feature set from a feature store on that model, and the output of it will become a new feature set which could later be used for different
models or further the line.
Usually, however, the problem I see with this is that the model output, it doesn't go through a regular data engineering pipeline which evaluates the quality of it, etc., etc. So nothing curates it, because once you apply a machine learning model on a set of features, you would then need additional curation pipeline to make it yet again available in the feature store. I would think about it like this, because yes, while
we can calculate drifts,
but it's not only drifts, all of the null values.
The model shouldn't produce, produce.
But it shouldn't produce. But that's what the data engineering pipeline solve, because nothing should output bad data, right? But it does. This is a very complicated idea, but you could definitely provide a model API out of the feature store. But I would say that to me, is just another abstraction layer, because that feature store provider will then have to manage models. It will have to deploy models. So you're basically just moving work from the one who trains the model and implements it to the provider of a feature store. So it could be.
It is not what the market today offers.
No. I haven't heard about it nowhere, to be honest, only from you. But it's a fascinating idea. So it would be yet another.
I'm just trying to understand what is the main difference between feature engineering being a Python function or a Spark script.
Spark script is deterministic.
But model, like trained model on a deterministic input, also depends how you implement it. But
you would apply it on already unseen data, right? So
but Spark script applied on unseen data is also it's also not deterministic, right? I still don't see why it shouldn't be like that, but for some reason it is not like that. Right?
I love the idea, and I know that definitely models are chained, right? They are chained together to produce a final result.
Exactly. With a setup where you have some of them, I asked about in the example with SAS, where we were building, let's say, lead scoring system. I said, okay, there is an API for going to Clearbit. Maybe Clearbit Insight also has models, right? So for me, it is not so distant idea. Anyway, I understand that it is not where market is today.
But
maybe there are reasons
it is idea to not necessarily test, but to at least talk about, right? I think that it could have its place.
Yeah, because we've been thinking within Neptune when we have product discussions and we from time to time we talk about a future of this space of MLOps space. And I think that's like at the beginning we had a few end-to-end platforms, big players that are still on the market. Then we have a wave of many startups trying to do something small and call it a new category. So it was pretty problematic to follow what is doing what is needed, what is not needed, how it should all be integrated. And I think that we are getting to the phase where we are normalizing the space, clearing things up. That's why I'm looking, what makes sense to be within one component where we really need to have two different components or more. And it was one of the items we discussed, shall model serving be part of feature store or not, or they're completely separate. The same or similar discussions we had among where we were comparing model registry and experiment tracker. I don't like the name experiment tracker because experiment sounds like something not production related. That's why we came up with another store, metadata store. Sorry for another, I'm not sure it's buzzword, but another store on the market. But yeah, like we try to get out of this not production quality sentiments that comes with experiment tracker. Anyway, maybe one day I will be following, your feeds. Maybe one day I will see feature model serving next to feature store.
Maybe, but model serving and model deployment to me, for example, are two different things.
Model deployment, I agree.
But then again, if you want to serve a model and produce results from it, then it's also deployment, also bundled into the same thing, because you can't outputs from a served model, you need to deploy it. So the feature store...
To some extent, yes. But like when you think about calculating of features via feature store, there is some level of computation that has to be happen somewhere, right? Mm-hmm. So we can also say, okay, it has to be triggered, it has to be executed. Are we calling feature deployments?
But that's batch, right? So for batch, true.
What about online, more like
real time? Okay, so it also makes sense because you compute features as they come in, but you wouldn't want to probably have your model in the same script as well, right? But
it is. I wouldn't recommend it, right? It is how you architect.
But the difference is between the fact that you query real-time API on demand and you compute features as they come. So these two concepts are coupled.
So feature. Oh, I understand. So there is no way to calculate features. Let's call it lazily, in a lazy way. You always need to calculate them, even though maybe you won't need.
That's a good idea. It probably could be implemented. So if you don't need a feature yet, but the data has already come in, only once you hit the REST API, only then you calculate the feature. It would also probably improve efficiency and decrease costs eventually, right? So that's an idea to look into for feature store vendors.
Aurimas, to sum up, maybe not to close things, for me it was, at least for me, it was very fruitful. Maybe we went sometimes too deep, but your posts are rather deeper. That's why I didn't want to talk in a shallow way. So if you can tell us, like for those who are not following you yet, where can we find you? It would be first question, and follow-up question, maybe harder one, but for me, super interesting. I am following you, so I am learning stuff from you, but where do you get your knowledge? I think you are not following yourself so much. So how do you do it? How you are being on top of things? How do you manage it?
Okay, first of all, you can find me on LinkedIn, naturally, Aurimas Griciunas. Follow me there. I'm also on Twitter. I'm also on Mastodon now, and I have a newsletter. It's coined Swirl AI. You can find me there as well. I put everything that I write in LinkedIn on my newsletter every week. I do have plans to expand what I write about in the newsletter, but that's how it currently is. And also, you will be able to probably find me next year on my YouTube channel as well, but that's for the future. And when it comes to learning...
You will be on our YouTube channel for sure with this episode, so there will be even more of you on YouTube.
So how I learn. So I definitely do follow a lot of our influencers, or not only influencers, just the people who speak about MLOps. And I definitely read the blog posts, including neptune.ai's blog posts, which are great, by the way. I do read a lot of technical books. I'll make it clear. So I would say that it's not that easy to know many things in that depth. So I also sometimes feel that I plateau at some level when I only read tutorials and other people talking about so I read books. So I read books about Kubeflow, I read books about Kafka, Cassandra, I read books about Airflow specifically, and not one, but several per topic. I also read lots of books on Kubernetes, for example. So
it is interesting. I was always skeptical about this because I felt that about particular technology, especially when it pertains to particular version, because I felt that it would be outdated.
You need to choose correct technology. So definitely I read the newest releases because, for example, for Kafka, they are coming out every year or two, new release of a book, which covers the latest ones. But I choose the technologies which are almost fundamental for the practice. For example, Kafka is definitely fundamental.
Give us 5 or maybe 3 for in the context of MLOps engineers, guys who want to do this job. What would be top 3?
So for MLOps engineering specifically, it's a little bit more complicated. Usually,
5.
No. I mean, usually it's easier to find fundamental things in data engineering because these are distributed technologies, etc. So you need to know about those. For MLOps, definitely designing machine learning systems by Chip Yoon. It was released this year, so it covers the life cycle of machine learning operations pretty well. I would also include Joe Race's book called Fundamentals of Data Engineering. Even though it's about data engineering, but these 2 books coupled together cover the entire life cycle of data from raw till deployment, I would say. Read these 2 books as a beginner, 100%, and then dig deeper. When I say dig deeper, then you should read at least 1 book about the statistics that go into machine learning, but I don't really have a very good recommendation for this. Yeah, MLOps is a little bit harder compared to data engineering. There are not that many books around that topic. So that's why I'm really glad seeing them popping out in the recent years. Because it's
Any plans for you to write a book?
I was thinking about it, but it takes a lot of time. And I think that return on investment is great when you think that people read it, but it's not true because I don't want to say that not that many people read these kinds of books, but it's definitely a limited amount of people when compared to, for example, just putting the knowledge online and reaching hundreds of thousands of people, right? So I do have plans eventually, but...
So Aurimas, I am keeping my finger crossed for you. I think we'll be meeting from time to time in the space. Thanks for today. Okay, Aurimas, thanks a lot.
Talk to you next time. Bye.
MLOps Live is brought to you by Neptune.ai. Remember that you can join us live at the next event and ask your questions. And you can register at neptune.ai/events.
And then make sure to search for MLOps Live in Apple Podcasts, Spotify, Google Podcasts, and anywhere you get your podcasts. Click follow and don't miss any episodes.
Thanks, and see you next time.